Welcome. My name is Carolyn Grimm, and I spent 15 years at the National Center for Education Statistics, where I served as director of the longitudinal study of middle grade students. After the federal workforce reductions that displaced nearly 100 education researchers in 2025, I founded Agora Education Research, a nonprofit dedicated to preserving that institutional knowledge and making sure the work doesn't stop. One of the ways we do that is by sharing what we know. So, if you've ever read a headline about test scores, graduation rates, or teacher pay, and wondered whether you were getting the full picture, this is for you. We're going to spend about 10 minutes walking through the handful of statistical concepts that show up over and over again in federal education data. You don't need a math background. You just need a little vocabulary. Why statistics matter. Here's the honest truth. Federal data doesn't speak for itself. Numbers get misread, misquoted, and misapplied all the time, not usually out of bad faith, but because the people reporting or acting on them didn't have the tools to interrogate what they were actually seeing. A journalist who understands standard error writes a very different story than one who doesn't. A policymaker who knows the difference between statistical and practical significance makes different decisions. That's what this is about. Count, min, max. These three are the first thing any analyst checks before touching a data set. And they're the first thing readers should ask about too. Count tells you how many observations you're actually working with. Is this a study of 50 schools or 5,000? Min and max immediately reveal whether there are outliers that might be distorting everything else. That university with 41,000 students, it's going to pull averages in ways that a typical institution won't. Always check the edges before you trust the middle. Mean versus median. This is probably the single most consequential distinction in everyday data literacy. The mean is what most people picture when they hear average. Add everything up, divide by how many. The problem is it's a pushover. One billionaire moves into a neighborhood and the average income looks great. The median doesn't care about the billionaire. It just finds the person in the exact middle of the line. Whenever you see data about income, wealth, salaries, or anything where a few extreme values exist, ask yourself, is this the mean or the median? The answer changes the story. Standard deviation. Standard deviation is how you answer the question, is everyone basically the same, or is there enormous variation? A low standard deviation means the data points huddle close to the average. Most states, schools, or students are performing similarly. A high standard deviation means the average is masking a huge spread. In education research, that spread is almost always the more interesting finding. When someone reports that the average reading score is 260, the standard deviation tells you whether most kids are near 260, or whether some are at 200 and others at 320, and the average is almost meaningless. Standard error and confidence intervals. Here's where we move from describing data to trusting it. Standard error answers. If we ran this study again, how different would our estimate probably be? A small standard error means we'd get roughly the same answer. Reassuring. A large one means our estimate is a bit of a coin flip. The confidence interval puts that into a range you can communicate. When you see 82% margin of error plus or minus 3 points, that's a confidence interval. It's not saying that the true number might be anywhere between 79 and 85. It's saying our method of estimation reliably captures the true value within that range. Standard error. The graphic walks through the concept in 3 panels. The full population, 3 individual samples each with their own mean, the tick mark, and then how those sample means form their own tight distribution, with the standard error bracket showing the spread of those means around the true population mean. Confidence intervals. This shows the classic way statisticians explain CIs, 20 repeated studies, each producing its own interval. 18 capture the true value, teal. 2 miss it entirely, terracotta. That's exactly what 95% confidence means. Not that any single interval is 95% likely to be right, but that the method captures the true value 95% of the time. We talk a lot about averages, but the shape of the data matters just as much. A normal distribution, the bell curve, is symmetric. The mean, median, and mode all land in the same place. But most real-world education data isn't shaped like a bell. Income is right-skewed. Most districts are clustered at modest funding levels, but a handful of very wealthy districts pull the tail out to the right, dragging the mean up with them. That's why the median is a better measure of typical in skewed data. Whenever you see a distribution that isn't symmetric, pay close attention to which measure of center is being reported. T-tests and statistical significance. T-tests are how researchers ask, did this actually happen or could it be a fluke? The p-value answers that question in a specific way. It tells you the probability of seeing a result this large just by chance if nothing was really going on. Under 0.05 is the conventional threshold. But here's the thing, people get wrong constantly. Statistically significant does not mean important. With a data set of millions of students, you can get a statistically significant difference of 0.2 points on a test. That's real. It's not random noise, but it almost certainly doesn't matter for a child's education. Always ask both. Is this significant, and is it meaningful? Universe and population. Every federal data set has a boundary, a defined universe of who or what is included. This sounds technical, but it has real consequences. IPEDS covers post-secondary institutions that participate in Title IV federal aid programs. If a school doesn't take federal aid, it's not in IPEDS, period. NAEP covers public school students in sampled grades. Private schools, homeschooled students, kids in non-tested grades, not there. So before you use a federal data set to make a sweeping claim, always ask, who is actually in this? The answer will tell you how far your conclusion can travel. Sampling. Most federal education data comes from samples, not from counting every single person or institution. That's not a flaw. It's by design, and when done well, it's remarkably accurate. The key question is how the sample was drawn. A random sample, where every unit had an equal shot at being selected, gives you findings you can generalize. A purposive sample, where you deliberately chose schools with a particular characteristic, gives you findings that only apply to schools like those. And a convenience sample, where you surveyed whoever responded to an email blast, gives you findings you should interpret very cautiously. The sampling method is the foundation everything else rests on. Surveys and weights. Surveys are everywhere in federal education research, and they're more complicated than they look. Response rate matters enormously. A survey with a 30% response rate is telling you about the third of people who chose to respond, which may be very different from the 2/3 who didn't. Survey weights are the technical fix for an unavoidable problem. Federal surveys deliberately oversample certain groups, rural schools, minority students, so researchers can study them with enough statistical power. But that means if you just add up the raw numbers without adjusting for those weights, you'll get a distorted picture of the overall population. Always check whether weights were applied. If there's one thing to take away from this, it's that data doesn't interpret itself. The same numbers can tell very different stories depending on whether you look at the mean or the median, whether you know the universe the data covers, or whether someone has applied the right survey weights. The researchers at Agora Education Research spent their careers making sure federal education data was produced, interpreted, and communicated correctly. That expertise is now available through the Agora Research Academy, including a full Statistics 101 course for anyone who wants to go deeper. Thank you.